So, as we know that Flutter is a powerful framework made by Google which allow us to build the applications for the platforms like Android, iOS and the web, and even now the Linux, Mac and Windows are also on the stable version of Flutter. So we can build the applications for these platforms from a single code base that is our favorite Dart. By doing so, most of the time if our project expands and we come up with a terrible situation where we have mixed up all of our business logic with the UI code, and then we start thinking and looking at our application which contain only the Dart code which depends upon each other, and that is the most terrible moment of Flutter developers. That is why having a state management solution along with the clean architecture in Flutter application is even more important than any other framework, and we will learn about the clean architecture in the next advanced section, and in this section we will only focus on the block. So there are a lot of state management solutions available for Flutter, but the best and the cleanest one in my point of view is Bloc and its subset Cubit. So we are going to learn both of them, but we will be using the Cubit throughout this bootcamp for building the applications. So the issue in our Flutter application is to separate the business logic from the UI code, and that's where the blocks comes in. So first of all, let's talk about what is Bloc. So Bloc stands for business logic component and is a design pattern that helps us to separate the business logic from the UI code, and the block pattern is particularly useful for building large, complex and scalable Flutter applications. But first, we will learn it by creating a small counter application on it, and then we will separate all the business logic from the UI in the Firebase CRUD. You can see in the 17th section in here. Here everything gets spaghetti, that we have the widgets in one library and we have the methods like this in the same library, and then also we have the same model class in the same library, which kind of makes everything spaghetti. So secondly, we will separate the business logic from the UI components in here, so that will become more clear to you when you go for it. So again, as I said, the block business logic component is a design pattern that helps us to separate the business logic from the UI code, and the block pattern consists of three main components: the events, block and the state. So what are events? So the events represent the actions that a user can take within the app, like a button click and some scrolling, etc. And the block stands for business logic component is the component that receives the events, processes them and returns a specific state. It also exposes streams of data that the UI can listen to and use to rebuild itself. So finally, we have the state. A state is really simple, which refers to the current condition or a status of the application at a given point in time. So that were three main components of block: events, block and the state. Event triggers on the UI, block receive them, process them, and in return it gives us the specific state. So to make it more clear, here we have a diagram of it. We have this UI on which some events will trigger, and these events will come to the block, it will process them, this will send requests to the data, it will give us the response, and finally it will emit the state on the UI. That will be the specific state according to the events triggered. So I hope this diagram make it more clear what is block and how its processing works. So first of all, initially we have a simple counter application where we have two floating action buttons, and here we have a counter. So when you click this add, this will simply increment the counter, and when we click this remove, so this will simply decrement the counter, and this is simply done by doing the set state to this state variable to simply keep updating the UI. So now after seeing this, there might be a question in your mind, like why bother about any state management solution when we have the set state? So there are a few reasons you should prefer to use a state management solution instead of set state. So the first reason is the separation of concern, which means with the set state, the business logic and the UI are tightly covered, making the code harder to understand, test and also the maintain. And a state management solution like the block separates the business logic from the UI and making the code more modular and easy to understand. So this was the first reason, the separation of concern. And the second reason is the scalability, meaning that the set state can become hard to control as the complexity of the application increases. And a state management solution like Bloc make it easy to manage the state of a complex application and ensures that the code remains maintainable as the app grows larger. So that was the second reason why you must prefer any state management solution like Bloc instead of the set state. So that was the scalability of the state management solution like Bloc or any other you like. And the third reason is reusability, which means that the sit stat make it hard to reuse the business logic across the different parts of the application, and a stat management solution like Bloc make it easy for us to reuse the business logic across the multiple parts of the application. And finally, we have the testability, like to write the unit test for our application, where the sit stat make it hard to test the business logic because it is tightly coupled to the UI, and a stat management solution like Bloc make it easy to test the business logic in the isolation from the UI. So it's worth noting that sysstat is not wrong to use in all the cases. Like if your app stat is simple and easy to manage, it's a good solution to prefer the sysstat. However, as the app's complexity increases, it becomes necessary to use a stat management solution like Bloc or its subset Cubit or any other stat management solution you like. So that was some reasons you need to keep in mind why we should prefer to use the stat management solution like Bloc in our application when we are dealing with the larger application. But right now, just for learning the fundamentals of the Bloc, we will for now use this Bloc in a simple app, and then we will go a bit further for managing the code of the Firebase basics we wrote in the previous section. So I hope that was a long enough overview of the Bloc that you need to know before working with the Bloc. So first of all, to use the Bloc instead of the sit stats in our application, first of all, what you need to do, simply keep everything as it is in the main.dart and simply create one directory in the week2 directory. That is 18 Bloc section 1. The 18 is because that is our 18th section of Bloc, and that is the section 1 of only this Bloc, and there will be also the section 2 to separate the business logic from this cloud file store, where we have make everything spaghetti in the single library. So inside this Bloc section 1, let's create a directory and name it Bloc. So that is our directory, and inside this simply create a directory of the counter, as we are creating the Bloc for the counter. So inside this counter directory, simply right click it and go to the new, and you'll find this Bloc class. Simply click this and simply name your Bloc. Let's say I will name it to counter and click the OK. So you will get these 3 libraries in the counter directory. So if you don't have this Cubit class or the Bloc class, you simply need to go to your settings, and inside you need to go to the plugins and simply in the marketplace search for the Bloc and download this Bloc. So the Bloc will be available to you to create it just like this. And if you're using the VS Code, simply go to your extensions and download the Bloc extension. So also that will be available to you in your any editor you're using. So first of all, we will start from the events, where we have an abstract class of the counter event. So how many events we are going to have in this simple counter application? So it's obvious from this simple application, we have only these 2 buttons which can be clicked and some actions can be performed. Like when we click this increment, it increments this counter, and when we click this remove, so it simply decrement this counter. So it's obvious we have only 2 events that will be triggered from the UI. So let's create the 2 events in here. So we are going to have a class, and its name will be the increment counter event, and that will simply extends the counter event abstract class. So that will be our increment counter event, which will be triggered on the UI. So let's copy it and paste it right here one more time, and simply change this increment to decrement, just like this. So that will be 2 events that will be triggered from the UI. And inside the stat class, we have a simple initial stat, and in this section we don't have any specific stat to deal with, but there will be stats to deal with in the next section. So you will see it when we go for separating the business logic from the UI of this cloud file store basics. So for now in this counter application, we don't have any specific stat to deal with, like to create it in here and simply emit that. So that stats will be just like this, and in the counter we have the error. It means we need to add one package in our pubspec.yaml file. So you need to have this Flutter Bloc package in your pubspec.yaml file, and after this simply pubget to resolve this error. So after the pubget completes, the error will be gone. or will be fixed. So the block, the business logic component, is a library of separating the business logic from the UI code, and to make it more easy in Flutter, the flex angle create the package of this Flutter block. So we can easily use this package in our Flutter application to use the block in our Flutter application. So you need to have this package while dealing with the block library in Flutter application. So we got the two events in here, and we don't have any specific stat to deal with in this counter application, but will be one in the next section. So we don't have any stat in here, and that will be our block where the events will comes in and will be processed, and a specific stat will be emitted to update the UI. So as I said, we don't have any specific stat to deal with in here in the block counter class, which extends the block. In here it has two generics, the event and the stat. So we don't have any specific stat, and we have only simple integer counter which each time increment and decrement. So we will replace this counter stat, and instead of this counter initial stat, we will simply replace this with 0. So that integer will be our stat, which will be changed every time when the events of the counter increment and decrement is triggered. So here inside the body of the super, it is saying on counter event to do implement the event handler. So instead of this counter event, we will replace this with our specific event, that is the increment counter. It has the same parameters event and the emit, and here we are doing emit the stat with the +1, meaning that every time this increment counter event comes to the block, it processes it. This will emit the stat, which in our case the stat is integer, will simply +1. So every time this event is triggered, so this will simply increment in the stat, which is integer. So we don't have any specific stat, we have the integer, so we'll simply increment the stat just like this. And the same for the decrement, we are going to have the other event, like on the decrement counter event, it accepts the event and the emit. So every time this event is triggered on the UI, so simply we will emit the stat -1 to decrement or minus the value from the stat, which is again, as I said, the integer. So just by doing this, we have successfully implemented also the block. We have the events, we have no specific stat to deal with, we have made our stat the integer that will be each time incremented and decremented when these events are triggered on the UI. And that is it for this simple counter application of the block. So after this done, what you have to do, simply go to your main data, and in here we have this material app. So simply we will wrap this material app with the widget block provider, and inside it has one compulsory property, that is the create property, and then it accepts the function which as a parameter accepts the build context and will give us in return our counter block. So simply import this counter block just like this. So what it means, we have provided our counter block on the root material app. The reason behind this is we want this block to be available to all the descendant widgets. Like when our app is initialized and it runs and gives us the output on the emulator. So before doing this, we have simply initialized the counter block on top of our root material app so that the counter block will be available to all the descendant widgets down the tree, so that we don't have to provide it in any other specific page, but this will be at the root. So meaning that all the descendant widgets that has the context will contain also the counter block. So simply you will need to provide that and use this block. So we have provided our counter block. Again, this will be available to all the descendant widgets so that we will be using it easily. So after this done, simply go down here and remove this counter from here, and also make sure you remove the set stat from both of these two buttons of the floating action. And here this is not going to be that counter as we have removed it from here. So we will wrap this text with the widget block builder, which again accepts the block and the stat, and in our case the stat is our integer, and it has the builder property which accepts the context and the stat. So the block builder widget in Flutter is a part of the Flutter Bloc library, meaning that it comes from the Flutter Bloc and it is used to rebuild the widget tree in response a new state emitted by the block business logic component. So like every time in the counter block, if this increment counter is triggered on the UI, simply it will emit a stat. So each time if the stat is emitted with the increment, so in the main.dart, this block builder will rebuild the stat of the UI and will give us the fresh output on the UI. And in this case, the stat is our integer that will be incremented and decremented when the events are triggered. So in here, instead of the counter, we will pass the stat in here. Or you can also change the name of the stat to make it more clear. Let's say our counter, and simply copy it and paste it in here. So meaning that it's our stat or also the counter. Now these two buttons will not work just because we also need to call the events on these two floating action buttons. So first of all, we have this remove button. So in here, what you need to do, we will do the block provider dot of context, and simply we will pass a type in front of the of that will be the counter block, and simply from this you will call this add method which accepts the event, and this add method in the description said notifies the block of a new event which triggers all the corresponding event handler instances. So here in the event we will simply pass our event of the decrement. So we will do decrement counter event, and that is it. So this will simply call the decrement counter event. So we have this block counter block in the context, so we simply do block provider dot of context counter block context and call the event from this. So this will simply trigger the decrement event on the UI, and in the block this will emit a stat with the +1. So simply by doing this will decrement the counter by 1, and copy this and paste it in here, and simply instead of the decrement counter call the increment counter. So that is it. Now after this, simply hot restart your application to see the changes. So we got this 0 in here. When we click this add, so this is simply working the same as it was before. So what we have simply changed, we have migrated our app from simple set stat to the block, and that was the event which triggers on the UI, and block process them and give us the stat, and using the block builder we simply rebuild the stat when it is emitted. So that is how we are getting the output on the UI, and that was the complete mechanism of the block, and this will become more clear to you when we use this block in a bit complex way or in advanced application, that is the Cloud Firestore. We have everything spaghetti in here, so we will use the block to separate this business logic from the UI code and will make it clear. So this will become more clear to you that how to use the block in the real-time applications and these methods. So that was it for a simple block for now. So we learned some fundamentals of Flutter Bloc, and we use it in our counter application to manage the state of it and also to separate the business logic from the UI. And we don't have so many business logic in this counter application, but we still use it just for learning the basics of the block library. Now we will learn about the Cubit, which is the subset of the block. So first of all, what is Cubit? A Cubit is a lightweight state management solution. It is the subset of the block package that does not rely on the events and instead uses the methods to emit new stats. Just like the block pattern, the Cubit also separates the business logic from the UI, and it uses the streams to emit the stats and receive events as functions. The main difference between the block and Cubit is in the way they handle the stat. In block, the stat is managed by a separate class called the block or business logic component, which holds the stat and exposes streams to emit stats and receive the events. In contrast, in Cubit, the stat is managed by the Cubit itself, and it also exposes streams to emit stats and receive the functions as events. And this Cubit reduces some boilerplate code by just removing the events from the middle, and simply the stat is managed directly by the Cubit itself. And there are the two main components of the Cubit. The first one is the Cubit itself, and the other one is the stat. The Cubit is the component that receives the functions as events, processes them, and returns a specific state, just like the block, but instead it has the functions instead of the events. And state again refers to the current condition of the app at a given point in time. And the architecture of the qubit looks something like this. We have the UI, the functions goes to the qubit, the request goes to the data, the response comes, and the states are emitted on the UI in the streams. And to listen to the streams, we will use the block builder or the consumer again to listen to the stream and rebuild the UI according to that. So that was some difference between the block and the qubit, and it was the theory of it. So now let's do it practically. So now we will implement the qubit in this counter application. First of all, in the main, we have the same code which we had in the previous section. We work with the block. Here on the material app, we provide the counter block so that the counter block will be available to all the discontent widgets so that we can use or call the events from it just like this, so that it will emit the stats. And here in the stream, we are listening to the streams that are emitted in the stream, and here it will rebuild the UI for us. And when you click this plus, so this will increment, and here this event is called from the UI and it goes to the block, it processes it and emit the state in the stream. And here on our main.dart, we simply listen to that stream using this block builder and simply pass our counter here, and every time it rebuilds this block to reflect the changes on the UI. So the same will be the qubit, but only the events will not be there, but instead there will be the methods of it. So to create the qubit here, first of all we will close this block, and inside this we will create a new directory. We will name it the qubit. Simply hit enter and we got this qubit directory, and inside this again create one more directory and simply again call it the counter. Hit enter and we got the counter in here. Now right click on that and go to the new, click the qubit class and simply name it counter and click the OK. And inside this we got the stat and the qubit. As we don't have any specific stat to deal with, so simply in the counter qubit, same like as we have done for the block, in here we have made this stat the int, and every time we are incrementing it on this event and decrementing it on this second event. So in the qubit we will simply change this counter stat to the int and also pass the 0 in the super constructor. So that's it. Now in here we are not going to call any events in here, but we are going to have the methods that will be called from the UI, and then this counter qubit will process them and will emit the stats in the streams, and the same block builder will listen it and rebuild the UI, and that's what will happen in this counter qubit. So to create the method in here, for the increment we are going to have a function of void type and its name will be the increment, and simply using the fat arrow we will do emit the stat by +1, and the same for the decrement. So copy this and paste it down here, change its name to decrement just like this, and simply the stat will be decremented when this method is called. And that was it for this qubit. When this increment is called, so this will simply increment in the stat, and we will listen to this stat as this is emitting in the stream, and just we will rebuild our UI using the block builder to listen the stream. Now after this, simply go to your main dot and here same like this counter block, simply change this block provider to the multi-block provider, as we are going to provide the two block and also the qubit, and this block and qubit will be provided the same way as the qubit is the subset of the block. Now inside this we will remove this create from here, and simply this accepts the list of providers. So open this up, and for the block we are going to have the same block provider as we have the one in here. Now we have the multi-block provider, so inside the list of it we got the block provider, the same create property which accepts the build context, and simply counter block, and the same will be for the qubit. Copy this, paste it in here. Instead of the counter block we will do the counter qubit and simply import it. So after importing this counter qubit, Now same like this counter block, this counter qubit will also be available at the descendant widgets so that we can use or call the functions from this counter qubit. So now in here we have the block provider of context. So we will simply copy this and comment this out, and on top of that in here we will paste this and simply change it to counter qubit. That's it. Now from this we are not going to call the add method to call the event in here, but instead we will directly invoke the function from it that will be decrement, as this is the remove button. So that's it. Now copy this and also comment this out and paste this in here and simply change this to increment. That's it. We are done with calling the functions from the UI. And now this is going to be the counter qubit but not the counter block, and everything will remain the same. The function will be called, this will go to the qubit, it will process it, will send to request the data, response will comes, and the stats will be emitted on the UI in the stream. So this block builder will listen to the streams and rebuild the UI, and we will see the answer or the changes on the UI. Now that's it for the qubit. Now how to start the application to see also the changes of the counter app with this qubit. So now when we click this increment, this works the same, and decrement. So that was it also for the simple qubit. So we have used the block for the counter in here, and also we have used the qubit for the same counter application, and you have learned so many basics of this qubit and block. So now you are familiar with the basics of this block and qubit. So in the next section we will finally be using this block and qubit to separate the business logic from the UI of this Cloud Firestore basics. So by doing this, that's how we can separate the business logic from the UI and manage the state efficiently in the app where we are dealing with some third-party databases like the Cloud Firestore. So it will become more clear to you when you go for this. So that was it for this section. Now see you in the section 2 of the blog.